This is an instructional video with practice on random sampling and population inferences. Random sampling and population inferences. Random samples. Everyone in the population must have an equal chance of being selected in order for the sample to be random. An example, a survey is taken of a favorite sport in the 7th grade, but only girls are surveyed. So only the girls are given a chance. This is not a random sample. So you have random samples or you have biased samples. So if it's not a random sample, it is biased because a biased sample is one that does not represent the whole population, like this one in the example. Read the situations below. Determine whether the various methods would produce a random sample. Justify your answer as we go through. So the senior class president would like to host an after-graduation lock-in. There will be games, gifts, and food. In order to decide if people would be willing to buy tickets and attend, she decided to conduct a survey. She will be selecting 25 students to meet and give input on the prizes, the food, and ticket prices. There are 500 members of the senior class. So one option is to select every 10th student as they get off the bus. This is not random because it only includes students who ride the bus. Another option is that she will ask the choir director to allow her to survey the choir. This is also not random, so this is not random. Because it includes only students who are choir members. So I'm just going to put BC for because. It only includes students who are choir members. Remember, in order to be random, it has to be an equal opportunity for all students. Another option, she will meet with the counselor who selects every 12th student on the school roster. This is going to be a random sample. Because it does provide an equal opportunity for the students. She assigns each senior a number and randomly selects 25. This is also a random sample. Because there is a specific method to picking the people who are going to be surveyed, and it did give every student the opportunity to be included. The next option could be that she makes an announcement that people interested should meet in the library after school. This is not random because it only includes the students who volunteer to participate. And then the last option, a roster of the senior class is printed and each student's name is put into a hat and the principal selects 25. This is a random sampling. Population inferences. Once a sample has been collected from a population, an inference about the entire population can be made by setting up a proportion. These inferences can also be used to compare different populations and make predictions. Now, most of us know what inferences are based off of our English and language arts classes, but just in case, an inference, we'll give you the definition there, is a conclusion based on evidence and reasoning. So we have several questions based off of this particular table. Eastside Middle School conducted a survey of randomly selected 6th graders to determine which elective they are most likely to participate in. The results are shown in the table. So we have 6th graders picking the electives of Spanish, theater, and art. How many students were in the survey is the first question. You would take all of the totals from the table and add them together. So 14 plus 20 plus 6 would give us our answer. So there are 40 students involved in the survey. What percentage of the students surveyed selected Spanish as their elective choice? So we have Spanish is 14 of those students. So that would be 14 out of 40. So that means I'm going to take 14, divide it by 40. Which gives me 0.35, and we know to change 0.35 to a percentage, we move the decimal 2 places to the right. So that would let us know that 35% of the 6th graders would be planning on selecting Spanish as their elective. Letter C. The school estimates that there are actually 350 students in the 6th grade using the sample about how many students can be expected to sign up for art. Well, art was 6 students, so that would be 6 out of the total 40. Remember, we said there were 40 total that were surveyed. So that would be 6 divided by 40, which gives us 0.15. And we said there's 350 students, so we're going to take that decimal point of 0.15 and multiply it times the 350 students, and that would give me 52.5. Now, I can't have half of a student, so we're going to go ahead and round that up to 53. So it would be about 53 students. Letter D, the school estimates that there are actually 350 students in the 6th grade, using this sample about how many students are expected to sign up for theater. So we're doing the exact same process, except now we're looking at the number for theater, which is 20. So that's 20 students out of 40. So 20 divided by 40, that one should be a pretty easy one, is 0.5 or half. And so then you would just take your 0.5 and multiply it times the 350, which leaves us 175 students. So 175 students are going to be interested in signing up for theater. Letter E says, the school decided to drop an elective in which less than 10% of the population is signed up for. Miguel says that since only 8th grade people sign up for art, it should be dropped. Explain why this is or is not correct. So he is incorrect. And it's because if we look at art, art was 6 out of 40. That was what we did up in C right here. And that ended up being 15%. Well, we can infer that the population will have about 15% of the students sign up for art, which is not less than 10, because it said it had to be less than 10. 15% is not less than 10. Number 7F, mark each of the following statements as true or false based on the data. The first one says over half of the students at East Middle will select theater for their elective. This is false, because when we worked this out earlier, it was exactly half. Because it was 20 out of the 40 surveyed. So that is false because it had to be over half. Combined, the Spanish and art classes account for 50% of the elective results. So we're going to take our Spanish and art, which is 14 plus 6. 14 plus 6 is 20. Then remember they surveyed 40 students, so that'd be 20 out of 40, which would be 0.5 or a half, 50%. And it says combine the Spanish and art classes account for 50% of the electives, so this is true. And finally, the last, out of the 350 students at Eastside Middle School, at least 150 will sign up for Spanish. Sorry, 120. So we have to figure out, based off of letter B, found out that 35% of them wanted to do Spanish. And that would be 0.35. We're going to multiply that times 350. And that did give us 122.5, which is more than 120, so this would be true. Pause the video and practice. Use this to complete the practice worksheet titled Random Sampling and Population Inferences. If you've been placed in a group, you will need to try to answer the problems first, then share. If you are uncertain how to begin, then you can ask the group for some direction or input, maybe on the first question, and then answer the rest of it independently and then share. Review your answers with your team, then restart the video and answer the questions, or make sure you have your final answers correct. If you're working independently, then answer the questions, then restart and check your answers. Random sampling and population inferences answer key. Be sure you have attempted the problems before you move forward to see the answers. Be sure the correct answers or any answers you have missed are corrected. The wording may not be the same as mine, but if it has the same meaning, it would be acceptable. So you have random sampling and population inferences. The Mitchell Junior High School newspaper staff conducted 2 samples in which 40 students were randomly selected to represent the entire 600-member student population. The results of the 2 surveys are shown below. And we have the 2 samples. One of them is at 7:45 a.m. a start time, 8:30 a.m. for a start time, and 9 a.m. for a start time. The directions say read each of the headings or headlines and explain if the statement is supported by the data. So headline A says over 300 students want to start after 8 a.m. So we have to determine if this is true or false. And so we look at sample 1. We are going to do sample 1, we're going to take our 18 from 8:30 a.m. plus the 10, because it said want to start after 8. We're going to add those 2 totals together, which ends up being 28 out of 40. And then if you divide, that would be 28 out of 40. 28 divided by 40 would be 0.7. And you multiply that times 600, so that would be 420 students, which is over 300, so this statement is true. Headline B says 8:30 a.m. start time was the most popular. This is true. In both samples 1 and 2, we see the greatest number of people chose 8:30. All right. So headline C says that the small percentage of students want to start at 7:45 a.m. So we're going to look at both sample 1 and sample 2. For sample 1, we would have taken our 12 and divided by 40. So 12 divided by 40, that would give us 40% of the students wanted that start time. If you look at sample number 2, that's 14 out of 40. So when you do your division there, 14 divided by 40, it ends up giving us 35%. So both of these totals together, this is not a small percentage, so this would be false. Letter D, less than 100 students want to start at 9 a.m. So if you use sample 1, we would look at, so we're going to start with sample number 1 here. That would be 10 out of 40. So 10 divided by 40 is 0.25. And remember, we surveyed 600 members, so 0.25 times 600. And that's going to be 150 students. So that is definitely not less than 100. So this one would be false. Our next problem, based on sample number 1, how many students from the entire student population preferred the 8:30 a.m. start time? So we are focused only on sample 1. So we would take our number from sample 1 of 18 out of 40. So that's 18 divided by 40, which is 0.45. We would multiply that by the population, the members of the student body there, 600, and that does give me 270 students, which is your final answer. That's 270 students who prefer the 8:30 start time. So number 3, based on sample 2, how many students from the entire population would prefer not to start at 7:45? You got to watch your wording. So the students that do not want to start at 7:45, there's 19 in one group and 7 in another from sample 2. So the first thing we want to do is add our 19 plus 7, and that's going to give us 26 students. That's 26 out of 40, which is the same as 26 divided by 40 for us to get our decimal. And then we would take and multiply that times the student body of 600, and that gives me 390 students that prefer not to start at the 7:45 time. And the last question, you're going to have a statement that you're given, and you've been asked to give an example of a random sample and a sample that is not random. So the situation is the school board member surveys parents to learn how they feel about the new school boundaries. So a random sample could be where they poll every 10th parent within the district. This is a very distinct way to be pulling information. That way you have a pattern that you're following. All the parents were included and able to be drawn from, so that makes it random. So a sample that would not be random could be just surveying the people that showed up for a school board meeting. Because that only includes the people who went to the meeting.